Hey, Precalc. So we got two pies here. We're gonna call one pumpkin, one strawberry rhubarb. Your job is to find the equivalent of two pie with the following denominators. I'd hit pause. I'm gonna go eat some pie while you finish up. Hey, welcome back. So, 6 pi over 3, 8 pi over 4, 4 pi over 2, 12 pi over 6 are our fractional equivalents to 2 pi. So today we're going to look at using coterminal angles. We just saw what is a coterminal angle, and now, thanks to the Little Prince, now we are going to learn to be able to evaluate trig ratios using coterminal angles. So just to recap, coterminal angles are angles in standard position. That means they start at 0 on the unit circle. Angles in standard position that share a common terminal side. It means they end in the same place. Extra rotations go around the circle in opposite directions. Either way, it's still a coterminal angle. They start and stop in the same place. So what's the difference between coterminal angles if they start in the same place and end in the same place? Well, 2 pi over 3 in green over here on the left-hand side, that's on the unit circle. We can find 2 pi over 3. But the red one, 8 pi over 3, while it is coterminal, that's not on the unit circle, which means we can't evaluate it. So if we need to find a coterminal angle, here's our process. If we're given an angle like 8 pi over 3, what we need to do is subtract one complete rotation, because every trip around a circle, every rotation, you start in the same place and you end at the same place. It's one complete rotation. So if I subtract 2 pi, it's going to give me a coterminal angle. It will have the same place on the unit circle, same coordinates. So I would evaluate it the same. So subtract 2 pi. However, since 8 pi over 3 is in fractional form, I will need to convert 2 pi into fractional form, which we did already in the do now. Those four fractional equivalents of 2 pi are the only equivalents of 2 pi in fractional form that we will need to do like 99% of the problems that we're going to see in pre-calc. So our objective here is to find a coterminal angle that is between 0 and 2 pi. And the easiest way to recognize if we are at our final answer or not when it is smaller than 2 pi is our final answer needs to be smaller than whatever equivalent of 2 pi we were subtracting by, right? Because that 6 pi over 3 I just highlighted in yellow, that is the equivalent of 2 pi in fractional form. So in order to meet the requirements of the directions, my final answer, 2 pi over 3, I know that I'm done because it's bigger than 0 and smaller than the equivalent of 2 pi that I just used. It's smaller than 6 pi over 3. Okay, example number 2. 21 pi over 4. If I subtract the equivalent of 2 pi, that's 8 pi over 4. Subtract that, it gives me 13 pi over 4. And when I compare 13 pi over 4 against my equivalent of 2 pi right there that I just subtracted, I see that 13 pi over 4 is still larger than that equivalent of 2 pi. It's bigger than 8 pi over 4. So I need to repeat the process as many times as necessary until I get a final answer which is smaller than this equivalent of 2 pi. So keep subtracting again. This time I end up with 5 pi over 4 as my final answer. I know that I'm done because 5 pi over 4 is less than 8 pi over 4. Okay, next example, negative 3 pi over 2. Well, so this time I've got a negative angle, which obviously is going to be too small. That is not between 0 and 2 pi. It's a negative angle. So this time I'm going to add the equivalent of 2 pi. And from our do now, we know the equivalent of 2 pi using the denominator of halves will be 4 pi over 2. So I added this time because I started with that negative angle. Final answer is pi over 2. Still checking my final answer by comparing it to that equivalent of 2 pi. Is my final answer smaller than 4 pi over 2? Yes. Awesome. Positive? Yes. I am done. Last example, number 4, starting with 17 pi over 6. So with sixths, I need to use that purple equivalent from the do now. So I'm going to subtract 12 pi over 6. And when I subtract to get my answer 5 pi over 6, compare that to this equivalent of 2 pi I just used to subtract. 5 pi over 6 is indeed smaller than 12 pi over 6. So I know it lies in that interval the directions gave me. It is between 0 and 2 pi. All right, let's look at evaluating now. So if I'm given a problem like sine of 8 pi over 3, when I look at that problem, I see 8 pi over 3. I can check my unit circle. 8 pi over 3 is not on there. So I'm going to find a coterminal angle, which we just did a moment ago. This is the same angle. It's still 8 pi over 3. So I'm going to find a coterminal angle using the process we just talked about. So sine of pi over 2 is going to give me the same value. It's an equivalent problem. Now I'm going to go to my unit circle and find out what is sine of 2 pi over 3. So here's 2 pi over 3. The y coordinate is radical 3 over 2. So I'm going to write that down as my final answer. Problem number 2, tangent of 21 pi over 4. Okay, well, that angle is too large. If I look at my unit circle, 21 pi over 4 is not on there. So I need to find a coterminal angle. Now, conveniently, we just did that problem. But if you hadn't, you would go through that same process until you get an angle which is on the unit circle, or at least between 0 and 2 pi. So in this case, I've got tangent of 5 pi over 4. That's an equivalent problem using a coterminal angle. I will get the same value for my answer. So let's go to the unit circle and find out what coordinates we have for 5 pi over 4 so we can get our tangent value. So 5 pi over 4 down here in quadrant number 3, circled in blue. For tangent, I'll need the y coordinate and x coordinate, which in this case are both negative radical 2 over 2. So I'm going to bring those, sorry, scrolling too far. I'm going to bring those back over here, create my triple stack fraction action. And since I've got the exact same thing as a numerator and denominator, including the negative signs this time, I know my final answer will be 1. Okay, problem number 3, we just saw that sneak peek. So I got sine of negative 3 pi over 2. So I don't want to evaluate a negative angle. I want to find a coterminal angle, which is positive. So I'm going to change this to the equivalent problem of sine of pi over 2 using that coterminal angle we just found a minute ago. Sine of pi over 2. Let's go to the unit circle and evaluate. So pi over 2 right up here is a quadrantal angle between quadrants 1 and 2. I need the y coordinate, which is 1. So I'm going to bring that 1 back to this problem. That'll be my final answer. Last problem, cosine of 17 pi over 6. Again, that angle is too large, so I'm going to find an equivalent problem using a coterminal angle. So cosine of 5 pi over 6. Let's go to the unit circle on this one. 5 pi over 6 over there in quadrant number 2. And cosine is the x coordinate, so I need that negative radical 3 over 2. And we'll bring that back as my final answer. All right. Evaluating trig ratios using coterminal angles. Let's get to it.